Hi there. Hello, everyone. Welcome to our webinar about AR Foundation. Welcome to all the people joining here on Zoom. Also, welcome to all the people listening to us on YouTube. As you can see, you can ask your questions only on Zoom. You can see that the Q&A section is very active now. I saw some people asking why there is no any audio or let me mute this one here. There were some questions why there's no audio or video turned on. So we expect to have around 200 or 300 participants. So just for the housekeeping to make it easy for us and for you, there is an option to enable you to talk and to turn on your video, but by default, this option is going to be disabled. So about the topic, about the AR Foundation, nowadays there are many different resources online that teach you about AR. And the technology running AR is evolving really, really fast. And to be honest, we could make this kind of webinar every few months just to catch up with the latest updates from different platform holders like iOS and Android with the AR Kit and AR Core. So the added advantage that we have here is that, many webinars, the Unity webinars or live events, they are very often oriented on Europe or US. So it's nice to have online event and webinar here in our region, Southeast Asia and Australia, New Zealand. We received many emails from you asking whether or not this webinar is going to be appropriate for beginners. And the short answer is yes. I'm going to assume that you have some basic Unity knowledge. So you should be familiar with the basic editor concepts. But this is something I call a beginner plus. So I'm going to start with very simple things. I'm going to assume that you are a beginner, and then we are going to work our way to a little bit more advanced concepts and topics. And the ultimate goal of today's webinar is to help you understand how we can use AR Foundation to create solid and believable AR experiences. But before we start, a few words about me. My name is Marek. I'm Evangelist. I started my career as a mobile game developer. I took a short detour to VR and AR, and later consoles, mainly Nintendo Switch. And now I'm an evangelist at Singapore office at Unity Singapore. And a big part of the evangelist job is to share with audiences like you all the new and exciting features like AR Foundation, meet developers in person at the events and to understand the problems. I also work on some very, very exciting projects for external clients with the field engineering team here in Singapore. You should see me here on the camera just to make sure that you're not listening to a robot or a machine. It's all live. I'm going to touch on many different topics today, and I understand that there's quite a lot of information to digest. So that's why we are going to record the entire webinar. The entire session is going to be recorded, and we are going to put it on YouTube very soon. So if you are listening live, my suggestion is that you don't try to follow on your laptop with editor things that I do. I suggest that you just sit back, relax, and look at my demonstrations. And maybe later you can look up the recording and try to recreate all the steps yourself. Some of the sections that I'm going to show you, they are pre-recorded videos of me manipulating the editor and doing different stuff in editor, and some parts are sped up. So I think you're not going to be able to catch up if you try to do every single step in real time together with me. Okay, so let me give you a brief introduction what today's webinar is going to be about, what are different sections that we're going to cover. So I'm going to go from this very beginner introduction, and I'm going to show you how to create this very basic AR application. This section should take us roughly about 20-25 minutes. So if you're more advanced users, you have to relax, maybe grab a coffee or tea and just wait this 20 minutes until we reach more advanced topics like tracking and some advices on the visual quality. I'm going to go through the Q&A sections, Q&A section every time I finish one of the sections, just to catch up with all the questions you have for me. And before we start, this is our Discord channel. So make sure that if you have any questions that were not answered today live on the webinar, make sure to join us on Discord. There is a special channel called AR Foundation Webinar, where it's a dedicated channel where you can ask all your questions. Okay, so before I start the installation part of the AR Foundation, let me give you a few examples from different verticals, from games, from construction engineering verticals, different examples of AR applications made with Unity. So this is one of the earliest, Pokemon Go. Not many people know that Pokemon Go was actually made with ARKit and Unity. This was one of the earliest AR applications using ARKit. This is the Angry Birds AR, also a really cool game made with Unity, released quite recently. Something from our region. So this is Markomatic. This is a guy from Victoria, from Australia, and he creates this really great hand-painted, hand-drawn art that later he augments with AR using Unity. So here you can see that what's happening is that when you bring your phone over this painting, he's doing this animation to bring this art to life. So this is really nice artistic media use of AR and Unity. And the next one I'm going to show you, this is something that comes from our Unity website. So this is Pharos AR. This is really interesting AR kind of collaborative experience. If you're more interested in that, you can go to the unity3d.com and take a look at that. It uses a lot of really cool particle effects and yeah, something really nice to check out. The next one I want to show you is some of the shopping apps that you might know, like Wayfair and IKEA. They use AR to help understand the environment and place virtual objects like furniture in your house. So you can preview it, how it's going to look like when you buy the actual sofa, place it in your environment. Actually, the IKEA app, they have a really good interface. So if you want to check how to make the user experience and UI right, IKEA is actually a very good example. The next one comes from the automotive. So this is a application developed by Infinity. And this allows you to use a car as a model. So it's a really big object model. And it allows you to preview different sections of the car that are inside that you normally wouldn't be able to see. And the cool thing about using Unity for that is that we have this plugin called Pixies that allows you to bring CAD models into Unity experience. The next one is Unity Reflect. If you are from engineering or construction company, you are probably familiar with this Unity feature. So Reflect is a way to bring this big BIM models into Unity experience. And basically what you can do, you can grab your BIM model from Revit and propagate the model, send the model over to every connected device. So this could be your iPad, could be your iPhone. Really, really cool feature. Okay, so now I'm going to do a proper introduction. So I'm going to tell you where to start, what are the requirements, how to install AR Foundation, and what are differences between workflows on iOS and Android. So first, set of requirements that you need to fulfill. On the developer side, so this is you need to have Unity editor with iOS or Android platform support, and you have to install some packages. I'm going to show you which ones. If you want to push your build, if you want to create a build for iOS, you will have to have a Mac OS machine. So it's not possible to create a build using a Windows machine for iOS, but the other way around is fine. If you are, let's say, on Windows and you want to create Android build, this is all possible. On the end user side, your user will have to have a Android with operating system 7.0 or higher. This is equivalent to API 24. And if they are on the iOS, they'll have to have iOS 11 or higher. Also, for some of the features like the face tracking on iPhone, it requires iPhone X or newer. So let me now switch to my Mac machine and show you how to actually install packages, create a project, and so on and so on. So here on my Mac, this is Unity Hub. I'm going to installs. You need to make sure that your Unity installation has support for iOS and Android. Here I'm going to create a new project, select the 3D template, and give it a name. So this is going to be my AR Foundation project. This is going to take a minute or so to import all the default packages. I'm going to switch my view to the default one. So this, when you install fresh Unity, this is how your editor is going to look like. Next, I'm going to show you how to install different packages in your project. So you need to go to Window, Package Manager, and from here, you need to find the AR Foundation package. So this is the actual AR installation here. You also want to make sure that you install the latest version. So in my example, this is 3.1.3. And after this is done, I want to also add support for ARKit. So I'm going to scroll down to ARKit XR plugin. I'm going to select the same version and click install. You can see that there is a list here of provided features like horizontal planes, depth data and anchors, face tracking, but there is no object tracking. And object tracking, this is something I actually want to do today. I want to show you how to track different objects. So to do that, I'll need to switch to the preview package. So let me show you how it's done. I'll have to go to advanced, click on show preview packages, click yes. And from here, I'm going to go to AR Foundation and select the preview 4.0. So this is the one that is required to use the object tracking. Okay, once this is done, you will see that I actually have some information in my console. It says that my ARKit provider is not suitable, so there's some errors in the console. And to fix that, you need to scroll down to ARKit XR plugin and actually match the version number. So this is 4.0. Match this version number with your AR Foundation. Once this is done, you can see that there are no errors and we can progress with our basic setup. Okay, so here I'm going to create a new scene, file new scene, and I'm going to go right away and save it as my, let's go here into the scenes and let's name it basic AR. Okay, and now because I added all these different packages, I can right click, go to XR and add different XR related component. So I'm going to add XR session origin. This one has already existing AR camera. So you can see that this is actual camera in my scene here. And because I already have it, I'm going to remove the main camera from the hierarchy. Okay, let me save the scene now. And let's add a second component. This is AR session. So AR session is like the basic component that's going to control the input and how the AR session is going to behave on our device. AR session origin is more for adding different subsystems like raycasting or plane detection. So with only these three game objects in my scene, the light, session origin, and AR session, I should be able to create a new build. So I'm going to save the scene, go to my build settings, add my current scene Here you can see at index 0, this is my basic AR. I'm going to switch my platform to iOS. This is usually going to take a few minutes. I'm going to click build, create a new folder here, and a new folder basic AR. And I'm going to name my application as basic AR. Once you click save, it's going to give you an error. So this one says, you remember I told you about different requirements that we need to fulfill. So this is one of them. Here it says that ARKit requires a camera usage description. So if we go to the player settings, I'm going to move it to the right here. We will have to give a description that's going to be prompt to our user when we request to use the phone's camera. So here, camera usage description, we need to give a message that's going to tell this is AR. This AR application requires access to the camera. Okay, let's clear the console. Let's try to build. You can see that when I click save, unfortunately, there is another message here. So you have selected a minimum target iOS version of 10. And the ARKit, you remember, one of the prerequisites was that we need to use 11, at least 11 or higher. So let me go back here and let's go to find a target minimum iOS version. You can see that here it's set to 10. So I need to update this to 11. And this should be fine now. So if I clear the console and press build and save again, okay. I think it's the last one. So now ARKit plugin only supports the ARM64 architecture. So the same story, we need to go to the project settings and we need to find the architecture section. And by default, this one is set to universal. We need to switch this one to support only ARM64. And with this one done, we should be able to successfully create a build. So let's press save. This is going to generate an Xcode project. That's why it's important that you're on Mac. On Windows, this will not work. So here we found the Xcode project. I'm going to double click on it. So this will bring the Xcode here in front. If I try to go ahead and press play now, it's going to give me an error because I need to manage my signing certificate. So here I'm going to enable automatic, select my team and provide the proper bundle identifier. So here I'm going to say only Marek. And now when I press play, it should successfully build to my device. You can see that I have my iPhone attached here on top. And after it's built successfully, I'm going to show you here on my device. It's going to show made with Unity icon. Okay, and this is the message. The AR application requires access to the camera. And you can see that we have the simplest possible AR application. Right now, it only shows you the feed from your device's camera, but this is fine. It means that our application is working and we can start to build on that. So next, let me show you exactly the same thing very quickly, how to do this on Android. So let me switch to my Windows machine. This is, again, Unity Hub. And in my installs, I want to add a new installation. You need to make sure that this is the final, not alpha, not beta version. You need to select the final version marked with F. You also want to select the Android build support. So this is important. And just for your quality of development, I suggest that you select these two as well. So these are going to import the Android SDK and NDK to your project. So you don't need to install them all yourself. So once this is installed, I'm going to switch to my projects and I'm going to go ahead and create a new project with AR Foundation. So here, new project, the 3D template, I'm going to give it a name AR Foundation webinar and save in my projects folder. Okay, so Here, first, let me go here and go to Edit, Preferences. So here, under the external tools, you can see that I have installed the JDK and SDK Android development tools. So Unity is automatically going to handle how we are creating the APK, and you don't need to install any additional software. Here I'm going to switch to the Android target. And once this is done, I'm going to do exactly the same thing as I did for the iOS. So I'm going to go ahead and install the required packages. So let's close this window here. Let's go to Window, Package Manager. I'm going to select AR Foundation and just click Install. And once this is done, here I'm going to build for the AR Core. So I need to find AR Core XR plugin and click Install. All right, and I should be able to create my build now. So I'll just quickly take a look. Let's go to add our AR session origin and AR session and remove the main camera from the hierarchy. You can see that they are exactly the same here. So the nice thing about AR Foundation is that you don't need to create two applications for iOS and Android. The application is going to be looking exactly the same on both platforms. Okay, let me save the scene as basic AR. Go to the build settings and add this scene and try to actually build it. I'm going to name it basic AR. And you can see that the error here is that my target SDK version is lower than 24. So I need to switch it here, update my package name. And now when I build, there is another error. This is related to the graphics API. So we need to remove the Vulkan graphics API because Android supports only, with AR Foundation supports only OpenGL ES3 for now. You can see that the APK was created successfully. You can also click build and run. If you click build and run, it's going to push this APK. It's going to push this file directly into your device. And it should appear in the list of the devices here. I don't have any device attached, so it's not going to find any. But this basically finishes the Android part of things. And moving forward, the workflow is going to be exactly the same for both Android and iOS. We are not going to do any modifications on either side. We're going to use the same components. And there's still a few differences. So here, there's a comparison chart that you can see. And actually AR Foundation, it also supports the wearable AR like Magic Leap and HoloLens. But because of the current lockdown, current situation with the COVID-19, I couldn't get to my office. And the only HoloLens device that we have is in my office. So I couldn't prepare this one for today. Today we're going to focus only on ARKit and AR Core. And you can see that the coverage is pretty much the same. There are only a few differences here. So the object tracking, the 3D object tracking is currently available only on the ARKit side, and some body tracking features and human segmentations, they are also only on the ARKit side. But from the previous experience, I think we can reasonably expect that it's going to be in the future, both platforms are going to try to catch up with each other, and they're going to try to match their features. Okay, before I move to the second part, let me quickly go through the Q&A section. I can hear you. Low res on Zoom. The screen is a little bit blurry. So my internet connection should be fine. Let me try to do one trick here. So I'm going to, on Zoom, you don't have control over how the video resolution is output, but you can enable or disable optimize share for full screen video clip. So I had this enabled. I'm going to disable this now. So later, please let me know if this is better now, if you see any improvements. YouTube stream resolution is okay. So okay, thank you. Okay, that's better. Thanks, Paul. Okay, so let me move to the actual creation of the basic AR application. All right, so I'm going to start with the basic description of the basic technology that's running AR. I think this is going to be very useful for all of you. Because I believe that once you understand the basic concepts behind AR applications, you'll be able to create better, more robust applications once you understand the tech that's actually running these applications. So one of the basic concepts that we have in AR is visual inertial odometry, and this is a technique that uses a combination of your device's IMU sensors. So this is accelerometer and gyro combined with your color camera from your device, and this allows your device to detect all these different points that you have highlighted here. They're called the feature points, and they are basically a way how your camera understands the world and how it positions your device relative to these points. So your camera is continuously analyzing all these images to detect these points. They can be mostly found on edges of the objects, on objects that have and images that have very high contrast, kind of chiseled and cornered shapes. You can find feature points very often there. But on the other hand, on flat surfaces, flat white surfaces, or the uniformly colored surfaces like maybe white wall or ceiling, it's not going to do a great job of detecting these feature points. And the more feature points, the better, because as I said, they're like a basic building block of many more high-level AR features and most advanced concepts like image detection, object detection, very often rely on these feature points. So your aim is to maximize number of these feature points to accurately track your device relative to the world and to do a good image tracking and object tracking. Okay, so because we already have covered this, I'm going to show you how to enable this feature point detection and how to visualize them using AR Foundation. And this is going to be the first step. The second step is going to be using these points to create actual surfaces like flat planes. And we're going to use them later to perform raycasting and place an object on a plane in AR app. So here I'm going to show you how to use a particle system to visualize your feature points. So back in my Mac OS, here I'm going to add a new component on AR Session Origin. It's going to be AR Point Cloud Manager. And you can see that this one is looking for a point cloud prefab. So this is something we need to create here. I'm going to create an empty game object, AR Point Cloud Visualizer. And I'm going to add a new component here. This is particle system. And because this particle system is going to be controlled via a script, I'm going to disable looping. Okay, so let's disable that. Also, one thing to notice is that the start size, right now it's set to 1. So one unit in Unity, it means that it's going to be 1 meter width. Okay, so 1 meter is going to be definitely way too much. So I'm going to adjust this to be something closer to 2 centimeters. So let's set it to 0.02. Simulation space is fine. Let's see the scaling mode. I'm going to switch it to the hierarchy. So the game object scale can also affect the particles. I'm going to remove the emission and shape because this is going to be controlled from a script. And in the renderer, we need to give a material to our particle system. So here I'm going to click on this button here and select a default particle system material. Okay, once this is done, this is the most basic visualizer that we can create with a very simple particle system, and this is going to be controlled by a script. So to do that, I'm going to turn it into a prefab. So let's create a prefabs folder, and let's turn my visualizer into a prefab and remove the one I have in a scene, because it's going to be instantiated from the assets folder. On my session origin, I'm going to give it a reference to my newly created prefab. And now when I build the actual project, what I expect to see is that my application is going to, let's click here, append. So it's not rebuilding the entire application. So what I expect here to see is that when I build, I'm going to see a lot of white particles with this default particle system material at the position of the feature points on my screen. Okay, so let's switch to the view of my phone. Okay, we should see made with Unity, yeah. The same message as before. And you can see that here it's showing us nothing now. And yeah, here it is. So you can see that in the places where we have more contrast, like edges and places with more features, we actually have this feature points detected by the AR algorithm. So let me show you one more trick. So this actually can be done automatically by the AR Foundation for you. So this particle system that we created, you can actually just right click, go to XR default plane, and this is a pre-made one. The only difference from the one that we created just now is that this one has different color. It's orange instead of white. So let's attach this one to my point cloud prefab. And if I save it and create a new build, this is going to look exactly the same, but the only difference is going to be the color of the particle. Okay, so this is the Xcode project. Let's switch to the view of my phone. And you can see that it immediately detects the feature points, and the only difference is the color. You can see that it doesn't get a good job of tracking feature points on my ceiling fan or on my wall, because there are not too many points to detect there. So let me move to the next step. The plane detection. So we are going to use this built-in AR Foundation functionality to detect planes on my desk and on my floor that we are going to later use to perform raycasting and to place the actual virtual objects on these planes. So back in the editor, I'm going to stop it here and move back to the editor. And here I'm going to go to my AR session origin and add a new component here. It's going to be AR plane manager. And you can see that it also wants a prefab, plane prefab, and we need to adjust the detection mode. So we can set it either to detect vertical planes, horizontal planes, or everything. I'm going to create XR default plane. So just like we created the default particle visualizer, we can create a default plane. And this one, instead of particle system, it's using a mesh to visualize it. Right now it's none. This is going to be set by our script. So the script is going to set all this for us. It has a mesh renderer with just a simple material. It's transparent with this orange tint. And down at the bottom, we should also see the line renderer. So line renderer is going to create this outline for our plane in a black color. Okay, so now let's turn it to a prefab. So exactly the same as with the point cloud visualizer. I'm going to drag it and drop it into my prefabs. I'm going to delete the one from the scene, and I'm going to attach it. Let me just quickly figure out which one. It's this one. I'm going to drag and drop it onto my airplane manager. And I'm going to recreate my build. So build settings, build, and save it, append. So now what I hope that will happen is that when I build it to my device, this should actually show me and visualize some planes. And we should see it as this transparent orange material with black outline. So here back on my phone, you can see when I move my phone around, it detects feature points, and these feature points, they kind of connect into a plane. Again, it doesn't do a great job with my wall, but as soon as I move it towards this posters that I have here, it finds feature points and it creates a plane on it. All right. You can see that here we have some problem with lacking of occlusion. So although the front plane on my table should cover the one on the floor, this was not happening. I'm going to later show you how to fix that. Another cool feature that you can find in the samples project, I'm going to later show you a link to the samples project, is the plane segmentation. So this is something that you can use to figure out whether or not the plane that you detected is a floor. It's going to give you estimation whether it's a floor, door, a table, or maybe none. It means that it's unclassified surface. So this is really cool if you want to create application that's going to maybe interact with doors, floors, and it's very useful. Next, we're going to perform raycasting. So when we touch on our screen, we will figure out where should we place our object in the virtual world. So raycasting is this concept where, from the point of view of your camera, so point of view of your user, you are shooting this kind of like a laser pointer that's going to hit on the object in the scene. Okay, so the aim of raycasting is to grab the value of this point and use it to place our object in the physical world. So here back in my Unity editor, I'm going to add a raycasting manager on my Air session origin, and I'm going to create a new script in my here scripts folder. And I'm going to here create a new C# script and name it simple raycasting. Okay, and I'm going to open this in Visual Studio. So right away, I'm going to remove the start method, and I'm going to add a new using Unity Engine XR Air Foundation. And this will allow me to add things like my AR Raycast Manager. So let's add the Raycast Manager here. Let's add a reference to the object that we want to spawn in our scene. So this is going to be object to place prefab, like that. And also we need to keep the reference. If we already created one, we need to keep the reference to that. Here I'm going to check every frame if I do have reference to the Raycast Manager, and if I placed my finger on a screen. So you can see that here I'm using the get mouse button down. So this is a very simple method that works both on Windows standalone when you use your mouse, but it also works with mobile applications. It's going to detect the first finger that you touch on a screen. Here I added reference to my Raycast camera. So I'm going to check if I do have reference for that. And with the camera, what I can do, I can create a ray to cast it against my environment. So here, Raycast camera, screen point array. I'm going to input my mouse position, but on a mobile application, it's going to be your finger position. And I'm going to feed it into my Raycast manager, Raycast. And we need a list of the hits. So here I need to initialize it. Remember, it has to be new list. If I just keep it as null, it's going to give me a an error. So here I pass my initialized list of hits. And if this one returns true, it means that we actually hit an object in our environment. Later, I want to check if I already instantiated one object. Okay. And I need to grab the first hit. So this is going to be the one with index 0. And I'm going to grab a pose. Pose is something that contains information about position and rotation of the hit. So here I'm going to instantiate game object prefab with my position and rotation from the pose. If I already instantiated it, so it's not null, I'm going to say object instance.transform.set position and rotation. So this is one method that's going to change both position and rotation. And if you are going to change both, this is a preferred way to do that. So if you can, don't set position and rotation separately, because it's going to take much more time on a CPU to perform this action. The optimized version to do both is set position and rotation. Okay, just before I go back to Unity, one last thing. Here in my Raycast manager, I actually can add a new argument. This is going to be my XR AR subsystems trackable type. And I can filter my raycasting against face, against image, or planes. So here in this application, I only want to check collision of my raycast against the planes. So once this is done, this is our super simple script. I'm going to switch back to Unity. Here in the Unity editor, I have to create a new game object to hold my script. So this is going to be raycasting. I'm going to add my script here, and it needs reference to the object that I want to instantiate. So I quickly create a sphere here, 30 centimeters by 30 centimeters. Let's name it raycast test object. And let's turn it into a prefab. All right, let's create a new material. Very quickly create folder, materials, and I'm going to create a new material here, just to not make it this simple gray. So I'm going to the name here doesn't really matter. It's object material. And let's change the hue to something more blue. So once this is done, I'm going to remove the one I had in my scene. I'm going to open the prefab and assign my new material to this object. Once this is done, I'm going to give a reference in my simple raycast script to this game object to instantiate, give it a reference to the AR raycast manager and to the camera. So you remember in the script, we added these 3 references that we had to assign here. So let's go back to the build settings. Let's press build, basic AR, append. Okay, so this should be it. This should be our basic AR application. All right, let's switch to my phone. And what should hopefully happen is that when I press on my screen, after the plane was detected, I should be able to instantiate my object on the plane. And when I press again, it's going to move the object to the new position, like that. So this is extremely simple, but with this script, what you can do, you can replace it. You can replace the reference to the object with anything you like. So here I have another build that I replace the reference with the Unity-chan. So Unity-chan is this anime character from Unity Japan. And you can see that here when I tap on the screen, it's going to instantiate this referenced object on your screen. All right, so this was the second part. And now we are going to progress to tracking. But before I do this, let me quickly scroll through the Q&A section. Okay, so could you show us the script for instantiating the particles on the feature points? So, so this one, if you want to see how this is done internally in Unity, you can go to the package manager, and you can check the script that's inside the package manager. So this is going to be AR point cloud visualizer. So you can go there and check how this is done. All right, so for the tracking part of the webinar, I'm going to cover, the main goal is to show you how to make this tracking robust. So if you have any glitches in your application, it's going to break the immersion. So you need to provide a good and, if you want to provide a good and believable experience, you need to make the tracking reliable. So first I'm going to go through the face tracking. I'm going to show you how to do image tracking and object tracking, which are actually very interesting topics. Let me go to the Q&A section. So will we make all the materials in the webinar available after the webinar? Yes, I'm going to make it available. And in one of the last slides, I'm going to give you links to two very important projects. This is the AR Foundation samples and AR Foundation demos. Hi, Craig. What happens when you turn off the plane tracking? So it's basically going to remove the visualization that I show you. You're not going to see the plane anymore if you turn it off. All right, let me progress to the tracking here. So in my, this is one of the projects I'll share with you. So this is the AR Foundation samples, and it has this several scenes. There's AR core face region. So this is example how can you do face tracking on AR core. And the second scene is the ARKit blend, face blend shapes. So ARKit is using the blend shapes. I'm going to show you the build of this demo. There's also eye tracking example, which is really, really cool. And you add it in a similar fashion. So basically you go to AR session origin and add the face tracking component. Here I'm scrolling through the ARKit documentation for AR face anchor. And this is when you want to create blend shapes, this is your point of reference where you can go and see how different blend shapes should affect your face mesh. So later I'm going to show the sloth example, and it's using this. I think there are 52 or 54 different blend shapes that can affect how your eyebrows move, how your mouth, and all different facial features move when you scan them with your phone. So here's the build of this first example. You can see when I move my mouth, it's the blend shapes act accordingly. So what is happening is ARKit is sending us this 50-something blend shapes into Unity, and we can reuse these blend shapes to control the animation of the mesh. The other sample was also the eye tracking. So I was actually surprised how accurate it is. You can see that wherever I look, it's tracking quite accurately. And you can use it to create some funny apps, like maybe eye lasers, something like that. All right, the next one is actually, I think is going to be more valuable for most of you, is the image tracking. So here I'm going to show you how to create the image tracking application and how to choose a right image target, because as you're going to find out, right image target is something very important. So here in my editor, you can see that I have imported some images. I'm going to right click, go to create reference image library. So this is an asset that's going to hold a reference to all different images I want to track in my application. Then I'm going to add this fallen leaves image, portrait, painting, and the Unity logo. So I have these 4 images. I'm going to select keep texture at runtime. so we can access it later. And on my AR session origin, again, I'm going to add a new component, AR tracked image manager, and my custom script here. I'm not going to write the script myself. I'm just going to quickly show you how the script looks like. So here I have this on-tracked image changed callback, and this is something you want to add listener to. So every time your tracking changes, you need to update information about the tracked image that you have. So this is the update info method. You can find the entire script in AR Foundation samples. So if you want to reuse it in your own application, this is going to be available for you. Let me switch back to Unity. Here we need few references, one to the camera, one to the prefab that we are going to spawn when we detect the object. So I'm going to reuse the sphere, and I'm going to create a build. And you can see that it gives me an error now. This is because I didn't specify the physical size. So here we need to provide what is roughly what's the physical size of my image that I'm going to track. And the size is in meters. So make sure that on iOS, you select the physical size. On Android, you should be able to skip this physical size settings, but on iOS, this is required. Okay, so here I'm going to rebuild again. But before, let me show you in the Xcode project, Xcode created this My Image library, and it has information about my images. So here, when I click on this icon here, it says the resolution of your image is low, both width and height should be at least 480. So every time you build your application and you have your images imported into your library, you want to go to this section and check, because Xcode is going to give you some really valuable information about your image target. So this is the first place to check if you have any issues. So let's switch back to my phone, and I'm going to, so this is my business card. You can see that it detected the Unity logo and it instantiated this game object. I'm going to pop some images here on my screen. I couldn't print them out because of the lockdown. So I'm going to just use my laptop screen. So you can see that it detected the second target, the third target, the fallen leaves. And let's open the painting. So you can see that even though it's not a physical object, it's on my laptop screen, it still tracks it quite accurately. So these were the images that I used. And the important thing that to look when you choose your images is how many feature points they're going to have. This is something I'm going to show you in a moment. But first, let me do a test. So I'm going to create a new image target that's going to have, let me just quickly do a small test here. I'm going to decrease the physical size, and I'm going to add a new image target. This is going to be just a white plane. So the white plane doesn't have any features, right? And this is going to significantly affect our application. And hopefully Xcode is going to give us some meaningful information here. So first, I decrease the physical size of the image. So here it says that the physical size is too small, and the physical object that you're going to scan, it has to be at least 1 inch. And on my white background, it says that the image has uniform color regions, low texture, low contrast, so there'll be no feature points. And the histogram of the image is narrow, and so the features are not evenly distributed. So this is something important too. So now when I build this application with my white background image target, what is happening is that my entire application appears to be broken. And this is due to the warnings that you had in Xcode, because you are using this white plane as one of your targets. your application is freaking out because the white plane doesn't have any feature points, so it compares like everything with nothing, and you end up with 3 frames per second and a bunch of warnings in your application. So make sure that you choose the right image targets. And just to give you an overview of what is a good target is this. So first, make sure that you enter the accurate physical size. So this is going to really improve the tracking, and on iOS, this is a requirement. Also, go to Xcode if you're on iOS, and go to the warning section to check what Xcode says about your images. Very often it will give you this meaningful information like your histogram is wrong. You also want to put your images on flat and sturdy surfaces. So when you print it, you don't want to be able to bend the paper because of course this is going to affect the tracking. You also want to avoid glossy surfaces because depending on your camera angle, when you look at the same object from different angles, this is going to give you some reflections, and it's not going to give you accurate tracking. Also, tip from me: choose high contrast images because these ones are going to have the most features. So, in the previous example, this would be the fallen leaves image. Unity logo is pretty good, but the features are not evenly distributed. They exist only in the center of the image. Okay, so next, object tracking. So this is, I'm going to show you some experiments that I did with object tracking. This is iOS only feature, and it will require you to use iPad or iPhone to perform the scanning of the physical object. You also need an app that you need to install on your device to scan the actual object. So this is scanning and detection app that I downloaded from the Apple developer portal. You can see that it has nice documentation. All the information is there. So I'm going to build it to my device, and I'm going to show you the tests that I did when I scanned the 3D objects to use in my AR application. So I try to choose different objects from my house to turn them into my object trackers. So I chose this teapot that looks like a house, the toy bus, this toy car, the biscuits can, this coffee can, a pineapple, a wine bottle, and a watering can. So a few days ago on Facebook, I asked you which one of these, what do you think is the most reliable target? Which one's going to give us the best results? So this is something I went on a mission to find out which one is the most reliable. And I placed these objects one by one on this piece of plywood. And I used the app to basically scan it, detect the feature points on my objects, and turn them into this 3D object target. So you can't see it very clearly here on my phone, but what is happening here is the scanning process. It has few sections. So first, you need to place your object on this flat surface. You need to define a bounding box. So this app is going to detect feature points only within this bounding box. Then you need to perform scanning. It's going to give you the percentage of how old did you scan the object. So iOS, Apple, they suggest that you scan at least 100 feature points. So if it says that you scan only 10%, it means that effectively you detected only 10 feature points. Once you scan a reasonably large amount of feature points, the suggested number is 100, but something like 90 or 70 in some examples should be fine too. So once this is done, you can adjust the origin of your object. This is something I didn't play around too much. And after you adjust the origin, you can basically test it to see how reliable the tracking is, and you can export it to use in your application. And after you export it, the workflow is almost exactly the same like with image targets. You create a library and you add your objects and you build the project, and it should work exactly the same. So this is me performing the scanning. From my experience, it took roughly 6 to 7 minutes to scan the object. One of the issues that I had is that I'm doing this on a balcony, so the light is not very uniform. It's coming from the direction of the sun, so it has, my objects had a lit and unlit parts. So this is something you should account for. Wherever you can, you should scan your objects in uniformly lit spaces. So here is a tracking evaluation. I took each of these objects and I tried to evaluate how well the app is doing with the detection. So here with this teapot, you can see that there are not too many feature points because most of the faces, they are just pure white. And the average time to detect this object was roughly 5,000 milliseconds. So around 2 to 5 seconds. The next one was this toy car. So you can see that it had quite a good contrast between the layers, the upper deck and lower deck. And this allowed me to get some quite significant amount of feature points and quite reliable tracking. And the average time to detect the bus was only 350 milliseconds. So this was one of the fastest object targets. So this is a very good one. Here, sometimes it even took only 30 milliseconds. So it's really good. The next one was this biscuit can. And I had quite a lot of features on the cover. So you can see that there was this, was there butter cookies, and the top had quite a lot of feature points, but the surface was quite reflective. So depending on the angle from which I was looking at the object, it sometimes lost tracking. It was not hyper accurate. And the average time to detect, you're going to see later, it was 600 milliseconds. So it's a little bit over 1 second. So this was a time to detect my object. I messed something up with the pivot. So you can adjust the pivot, and you can see that here I did something wrong with it, and it's a little bit offset. Something I also noticed is that when your device is getting really, really hot, it's going to affect how well your device is going to track the object. So don't overheat your phones. All right, the next one was the coffee can. So the coffee can was pretty good, but there was a quite significant difference between the front of the can and the back of the can. So you can see that in front, I had a lot of this nice drawings, but the feature points on the back, there was this fine print that didn't give me too much of a accurate tracking. So eventually the average time to detect was 2000 milliseconds. So it was not the best target. And as I mentioned before, there was a big difference between the front of the can and the darker side of the can. Next, we had one person that accurately guessed that pineapple was the best target. So this is something I didn't expect, but actually I managed to scan 90-something% of the required feature points, and the tracking was super stable. I could easily track it from the darker side and the lit side of the object, and the average time to detect it was only 300 milliseconds. So this was really, really nice, reliable target. And I could track it from any side, from the top, from the back, from the front. That's really, really good. But of course, you have problems. This is something I didn't test. If I would have the second pineapple, next time I would like to compare it, how it's going to when I train it on one target like this, how it would behave with a different pineapple. I'm not sure about that, but this is something that's worth checking. And the last target, the second but last, and the wine bottle. So this was a little bit of a disappointment because it didn't detect too many feature points. I could only scan 60, and I didn't want to catch any more. I think I ended up with 80 in the end, but most of them, they were located next to the label. And eventually, I couldn't track it at all. So here I say the average time detect was infinity. And I think it's mostly because of this glossy glass reflective surface that really, depending on the angle I was looking at it, it gave different results to my camera. So this wasn't really the most reliable object to track. And the last one, here the surface is also very glossy metallic. So I had a lot of reflections, and I couldn't collect too many feature points. There were only 60. So I think it was the lowest number from all the targets. But the tracking was surprisingly accurate and surprisingly fast. The average time to detect it was 400 milliseconds. So it's really fast and very reliable. And I think it has something to do with the asymmetrical shape of the watering can. So I think there is some potential in it. So just to sum up, the pineapple one, it was the best image target I tested, very reliable from all the angles. It had the most number of the feature points, and it was very fast to detect. The toy bus, the biscuit can, and the watering can, they were all pretty good, but the worst one was the bottle. I think it was mostly because lack of the features. It's uniformly dark, and the surface is very glossy and reflective. So just to sum up, these are tips I want to share with you. If you create your own object targets, what you need to look at. So first, scan your objects in a uniformly lit space. So don't do this at the balcony if you can. Bring it inside and maybe set up some lights so it's uniformly lit from around the object. Choose the object with a lot of features on the surface. So just like pineapple had a lot of this contrasting bits and pieces that created a lot of feature points that allowed for the accurate tracking. Also, you want to avoid reflective surfaces because they are going to affect how your object is seen by the camera from different angles. And also don't use soft objects like plastic bags. I mean, you shouldn't use plastic bags anyway, but the soft objects are going to change the shape throughout your lifetime of your application. So this is something you should avoid. The watering can was really surprisingly well tracked. So I think there's something with the asymmetrical objects. So if you have objects with this broken symmetry, I think they can be scanned pretty fast. And also place your objects on surfaces with little to no features, like the plywood I had, or the maybe white piece of paper, black canvas, something like this. All right, before I move to the last part, visual quality, let me go through the Q&A section. Is it possible to use Oculus hand tracking SDK with an AR camera? So I'm not sure about this one. My colleague, he knows more about Oculus, but I guess if this is something that any SDK that doesn't require the actual hardware, only feed from the camera, if the Oculus hand tracking SDK only requires image from the camera, this is totally fine and you should be able to do that. But most of the SDKs from different platforms, they actually are required to run on a specific hardware. So this is something to check. The recording can be watched back later, right? Yes, that's correct. We are going to put the recording on YouTube. Is there a way to test AR functions on the editor? So we had this app that you were able to connect feed from a camera with the editor, but right now I don't think it's available. Can I deploy AR core build to an Android from a Mac? Yes, you can do this. So this is totally fine. You can create Android build on Mac, but you can't do the other way around. So if you're on Windows or Linux, you're not going to be able to open the Xcode project. Is it possible to combine movement AI with AR? For example, autonomously moving car, navigating around furniture in the room. Yes, this is totally possible. So you could create like a virtual environment, maybe put some waypoints on your map and navigate around the waypoints. So the question was that the AR Foundation supports HoloLens. So is there a plan to add image tracking for HoloLens? So this is something I need to check. But the information should be available on the landing page for AR Foundation. If it's not, I'm going to check it later. So the question is, does Windows Android have an equivalent of those image target warnings? So I didn't check it for Android, so I'm not sure about that. I only checked for the Xcode. So with the new iPad Pro 2020 featuring built-in LiDAR, can this new sensor be used to improve data capturing? So I think definitely yes. So one of the problems with current AR technology is that you actually you are required to move your device from left to right, up and down, because what's happening is that as you move your camera, the images that come to your device, they are from different points of view, and there are some algorithms that detect differences between these point of views to try to capture depth of different feature points. And with things like LiDAR, this is not going to be the case. You're going to just scan the laser really fast around the environment, and this is going to give you quite reliable depth information. So I think this is definitely going to be a game changer, and it's going to improve AR and AR Foundation quite significantly. Yeah, this is going to be a really, really cool feature. Okay, so one of the questions was, can I recommend any phones that don't overheat? So unfortunately, I can't give advice on this one. So there was a quick question from Craig. I think, Craig, you asked this question on email yesterday. So what causes the AR world scene to drift? So sometimes when you have your experience, you hold your phone on your tracked image target or the object, and the entire thing just starts to drift around. So of course, this is undesirable behavior. So to eliminate that, you basically want to track your objects within the environment that has a lot of feature points. So if you are lacking feature points, let's say you are testing on a white wall with 0 features, this is going to look horrible, and it's definitely going to drift. One thing that you could look at is that in the AR session, there is an API that you can access to check how well the device is doing with the tracking. So you could check if the tracking is reliable, and then maybe prompt your user to move phone left and right to detect more feature points. And what I noticed from my experiments is that when the device overheats, it reduces the tracking quality. So when I was scanning the objects, especially when I scanned them for like 10, 15 minutes, the device was really hot. And then my objects they drift all over the place. So you want to make sure that you create a performant experience and you don't overheat the device. So Travis is asking how the device is knowing whether it's a door or wall in the segmentation example. So I'm not entirely sure how it's done internally, but I guess this is using machine learning and some segmentation algorithms. So how it's done is you basically train a machine learning model on some example data. You provided positive examples of a desk, of a floor, of a wall, and then your machine learning model is going to estimate how likely this surface is going to be door, floor, and so on and so on. All right, let me move back to the presentation. So the last section I want to share with you is the visual quality. Here I'm going to just briefly talk about light estimation, environment probes, plane occlusion, and SRP integration, and some UX and UI improvements that's going to maybe not increase the visual quality, but overall experience of your application. So this example, this video, it comes from the promotional materials of the first AR core. And you can see that what's happening here, we have a 3D model that's reacting to the change of the lighting environment. And the very first examples of the light estimation, it was only calculating the mean value of all the pixels in your image. Right now, these algorithms, they are more sophisticated and they quite accurately predict the direction of your light and some additional components. So here in my editor, this is from the project AR Foundation samples. Here you can see that I go to my AR session AR camera. And if you scroll down on the AR camera manager, you can select the light estimation mode. So you can either do simple light estimation or you can add more sophisticated features there. And here in my script, I'm basically adding a listener to the frame changed event. And here I can capture the light estimation, average brightness, average color temperature, color correction, the direction of the light, and so on and so on. So this is really cool and definitely try to use it. And this is how it looks like when you build it. You can see that I have this arrow in the middle that's trying to estimate where the light is coming from. It's artificial light, so of course it's not going to be super accurate. I try to play around with turning on and off lights. So you can see that it definitely affects the brightness and the color temperature of the light. The next thing that's really going to help you is environment probes. So environment probes, these are the features that are very similar to reflection probes. And how they work. When you move your phone around the environment, they're going to collect images from your camera to generate a cube map. So here's me just moving my camera around the room. And you can see as I move around, my phone is collecting more and more images and feed them into this reflection probe here, this environment probes. So this is something you want to add to your application, especially if your 3D objects have reflective surface. So they can look more and more convincing and believable. The next one is the plane occlusion. So plain occlusion helps you to hide objects behind planes or even different objects. And let me show you what I mean by this. So in this example, I have 2 overlapping objects. And by using some custom shaders, we can make one appear in front of the other. Sorry, let me come back here. We can make one appear in front of the other. And since the planes are semi-transparent, this can be quite a difficult task. But fortunately, we have a shader for you that can do this automatically. And again, this is going to be in the AR Foundation Samples project. So here in my project, I'm going to go to the occlusion example, plane occlusion, and it has this plane with the occlusion material. And the only difference from the normal plane is this shader. This plane has just a special shader that here you can see in this example, it accurately occludes objects behind it. So if you want to create this greater immersion, this is something definitely you should use in your project. All right, there were some people that were asking me, especially when I go to the events, how to integrate your AR Foundation with SRPs. So the very short answer is that the integration with URP, the Universal Renderer Pipeline, it's very easy, but HDRP, it's not supported. So let me show you how to do this with the URP. So if you want to add URP support to your AR Foundation app, you need to go to the package manager, install the URP, and go to your project and create a new folder, rendering. Here I have to create my pipeline asset. So this is going to be create rendering pipeline assets. I just named it here AR Foundation Forward Renderer. So the second one, the second object here, this is the renderer. And we need to add a new feature, this new AR background renderer feature. And the only thing that it does, it basically adds the camera image to your backplane of your camera in the rendering pipeline. And the last thing to do is you need to assign, in the graphics setting, you need to assign a pipeline asset. Also, if you updated your project from built-in to SRP, you need to go to render pipeline and update your project materials. This is going to automatically detect all the standard materials that you use in your project and convert them to the rendering pipeline equivalent of this material. The very last feature I want to talk about today, it's something that you can find in the AR Foundation demos project. And this allows you to create this instructional UI with animations that's going to guide your user throughout the experience. And you set it up as a sequence of goals. So these goals that you set up, like find a plane, tap on a screen, these goals, they exist in a queue that you need to create in your manager script. And every time you clear element from the queue, is going to move to the next one. So let's say in the basic AR, we want to first make our user to move the phone around to find the plane. Okay, so this is our first goal in the queue. Once this is done, we remove it from the queue and we move to the second element. So we ask user to tap on a screen to place a virtual object. This piece is done, so we remove it from the queue and we can start the experience. So this is a recording of this. So here I move the device slowly, tap on a screen to place the object. So let me play this one more time. So this asset basically allows you to add this really cool animated UI that you can reuse with this queue system to guide the user through the experience. Because what we very often see is that many people who try AR for the first time, they are lost in the experience. they don't know what to do, they don't know where to start. So I think it's really important that you give them meaningful information about what they should do with their phone, with their device, and you should guide them with this informative UI. And you can download this from the asset store. If you look for AR Foundation demos, onboarding UI, this is the asset you look for. So we have some predefined, like find an image, move the phone, find the face. We have all this pre-made animated UIs that you are free to use in your application. All right, and if you want to try it yourself, these are the links that you definitely want to try. So if you go to the GitHub, Unity Technologies, AR Foundation samples and AR Foundation demos, these are the two repositories that have all these different examples I tried today. So if you have time, please go ahead and download them and try it on your own computer. Before I finish, I want to show you kind of a teaser of what I want to do in the next webinar. And it's kind of related to what we did today. So the next webinar, I plan it to be about AI and machine learning. And here I made a quick example of how you can use AI in the AR application. So here is a video from my phone, and I try to put different objects on my couch. And I use this pre-trained machine learning model to try to estimate how likely this is going to be a remote controller or any other object. So here you can see it quite accurately guessed this is a remote controller. This is a wallet. This is a espresso cup, coffee mug. So you can see that it quite accurately detects and estimates what kind of object it's seeing in a camera. So as I said, the next session, this is going to be the 19th of May, and it's going to be about AR, AI and machine learning in Unity. So for verticals like games, this is going to allow you to create nice and realistic AI behaviors in your application. And for engineering construction, it's going to give you an ability to train and evaluate machine learning models in Unity. I think it's a really, really cool feature. This is something that that our machine learning team created. So this is a procedural animation that's using physics. So this guy that's running here, he doesn't have any predefined animation. His movement was trained through the machine learning process. Actually, tomorrow there will be an announcement about machine learning. Unfortunately, we can't do the announcement here today. Maybe if we grow the webinars to 2,000 or 3,000 viewers, then we are big enough to make big Unity announcements here. But for now, you need to tune in for today's blog post. We are going to give you an update on the machine learning agents. So make sure to sign up for the second webinar if you want to learn how to bring your machine learning model and maybe add it to your AR application. So let me quickly go through the Q&A one last time. So does UIQ support scaling, rotation, elevation? This is something I'll have to check. I believe I'm not sure now. Sorry about that. So is there an API for AR indoor localization? There's no explicit API that does this, but with features like segmentation, where you can differentiate between doors, walls, and floors, you could definitely do something like that. With indoor localization, one of our evangelists, oh my God. Yeah, one of the evangelists, Dan Miller, he actually created example on how you can create indoor localization. So most of these applications, they start with one image target, object target that basically defines the start of your experience. And then it basically shows you step by step which direction you should go. Can I build an AR app in Windows for iPhone? So the short answer is yes, you can build this application, but you won't be able to put it on your device. You won't be able actually to create a build of this application unless you use something like Unity Cloud Build. You will be able to generate the IPA, but you still need, if you want to test it with Xcode, you will need Mac OS. Can I zoom the 3D model example that you show? Yes, you can totally do this. And I believe that one of the AR Foundation samples in a project, it's doing exactly this. So go ahead and check this out from the GitHub. Is there any way to connect it to Instagram or Facebook? So this is a great question. And very often if you want to create like a full experience, you want to connect it with your social media or other applications. This is not something that you have outside of the box in Unity, but there are definitely some C# APIs that you can use to connect to these services. How to start to introduce AR to companies and what kind of company for now that needs AR. So this is a question more about the business side of things. I think many companies use now AR for visualization. So let's say in the construction companies, you can bring your iOS device or Android device and use it on the construction site to preview different building elements, things like that. Maybe for marketing purposes, like the car companies like Infinity, creating an apps that can help you to preview what's inside the car. So definitely marketing applications, things like IKEA app. I think they are definitely popular now. So will the Discord be the hub for each of these events? So yes, I think Discord is definitely going to be a hub where we can discuss these topics before and post webinar. So if you have any questions that were unanswered today, you should definitely, sorry, let me switch back here. You should definitely check out the Discord, and yeah, I'm going to answer the questions that were left unanswered here in the Q&A section. So yeah, but some of the bigger announcements we are also going to make on Facebook. The question is it possible to constrain game object within a window so that it's only visible inside that shape with the AR camera, something like a minimap with 3D objects? Yes, this is something that you totally can do. And I think all these AR portals that you can find on the Unity Asset Store, they're using something similar. So maybe you can try to Google on how to create AR portal. And this is going to be a very similar technique to something that you need. All right, so let me move here. So this is our Facebook for Unity, Australia, New Zealand, and Southeast Asia. If you don't follow us yet, you should definitely like our website, our page on Facebook, because this is a place where we are going to give you the newest updates and post information about webinars, Unite events or developer days, anything like this. You should definitely tune in on Facebook to get all the latest info. I would really like to know what you think about today's webinar. So please, if you can, fill in the survey. I think if you close the Zoom, it's going to automatically bring and open a web browser with this link, with the survey. So I'm really interested in what you think about today's webinar. We're still experimenting on how it's going to be looking like in the future. So please let me know your thoughts in the survey. And that's it for today. Thank you very much. And please join us on Discord. So if you wanted to ask any question that I missed in the Q&A section, or you didn't have time to ask this question, post it on the Discord. So there's a specific channel, AR Foundation webinar, that is dedicated to things about today's webinar. So once again, thank you very much, and hopefully see you in the next webinar. Thank you.